Here's pre-calc. It's a mini lecture for lesson 1.2.2, and it says how can I undo complicated functions. This is just all about inverse functions and how they can undo each other. And so I think I'll do this problem with you, and then there is a resource page that I'll give out and let you kind of work your way through that. So Sean is a factory manager. Sean is a factory manager. She knows that on any given day, n employees can fill P equals 2n squared minus 8 orders. Graph the given function and analyze the situation, state a domain that makes sense in this context. So I think I know how to graph it. It's just y equals 2n squared minus 8. So that would be a parabola, and it would be shifted down by 8 and stretched vertically by 2. So it's just, the problem is, like me sketching a graph, not super accurate, but it's going to have some kind of shape that looks similar. This y, similar to this. I don't know if this is going to show up, but I do have it up on Desmos, so I'm going to see if that'll show up in the recording. I'm not sure if you've been able to see it or not, though. So anyway, this is how it looks in the Desmos, and I can see from the graph that this is -2 and +2. Okay, I'm going to go back to the... I'm not sure if that screen flashed for you or not. I tried to show a screenshot of Desmos. But basically, you can use graph paper, or you can just use the equation to answer some of these questions. So what domain makes sense? Well, this is a problem about employees being able to fill an order. So n is the number of employees. So we can't have a negative number of employees. And we can't have a number of employees like 1.5 employees. You know, we need to have either 1 employee or 2 employees or 3. It looks like 1 employee can't do it by themselves because 1 is not on, 1 kind of misses the graph. Well, it doesn't miss the graph. We've got negative number of, what are these things they're making again? Well, it doesn't say what they're making. It's just how many orders. So 1 person would make a negative number of orders. So that doesn't make sense. So I would say the domain for letter A, the domain should be x is greater than or equal to 2. Because it looks like if you have 2 employees, you don't actually not even, well, or you could say x is just greater than 2, because if you have 2 employees, you make 0 orders. So I would think you would want more than 2 employees. And let me check on that real quick. Yeah, so they want, so in the teacher book I looked and it said we want at least 2 or 3 employees to fill a minimum number of orders. So this is fine. And then for letter B, it says how many orders can 10 employees fill in a day? So I could just plug the 10 in here. So that would be 10 squared is 100 times 2 is 200, and 200 minus 8 I think is, it's not 198, it's 188? Wait. 192. I had to count that on my fingers. That's, shouldn't have said that out loud. So that's how many orders that 10 people can produce. And then how many, on Monday 120 orders need to be filled. How many employees are needed on Monday? So they need 120 orders. So I would go like And then I need to find out how many employees. So I guess I wish I had a calculator. Just that would be a handy thing to have when I'm making a math video. I'm going to have to get one because, okay, 128. Oh no, I don't need one. I don't need a calculator because 128 divided by 2 is going to be 64. And then if I square root both sides, then I have n is equal to 8. I don't want the negative. So I would, if I want to get 120 orders done, I need 8 employees to do that. And then it says on Tuesday, 64 orders need to be filled. How many employees are needed on Tuesday? So of course I can just take the original equation, put a 64 right there. So I'm adding 8. I do, okay, half of 72. Is half of 72 36, I hope? We'll just say it is. So n would be, if I square root both sides, n would be 6. I need 6 employees if I want to have 64 orders. And then it says, Sean likes to save time and plan ahead, so she wants to program her computer to take the number of orders that need to be filled and assign the correct number of employees to work. What equation does she need to program into her computer? Alrighty, so there's different ways you can do it. I think what I would do is, I just noticed every time I'm doing this calculation, I ended up having to add 8. I kept having to, like when I did it here and when I did it here, I had to add 8. And then I had to divide by 2. And then I had to take the square root. So I think I would have to go x plus, well, not x, let's say n. I'd have to go n plus 8 divided by 2 and square root. And that would give me the number of orders. What were we calling it? P, I think? I can't remember. P. So I got that just by, I kind of common sensed it. There's other ways to do it. You can actually switch. You could just swap the n and the oh, it was supposed to be a p. You can swap the x and y or whatever and resolve it, or maybe we can, when we're in person, or maybe together as a team, you guys can talk about other ways to find an equation. So anyway, if I graph this equation, I'm going to graph it into Desmos. I don't know if you're going to be able to see it when I switch over to Desmos though. So I'll graph it in Desmos. Y equals square root. I'm just typing it in, and if you can't see what I'm doing, just know that you can get your own computer and type it in. N plus 8 all over, divided by 2. So what I got was I'm going to write it in case you can't see my Desmos. What I got was something that looked like this, and if I would have allowed the negative numbers in, it would have actually gone down like this too. And those are inverse functions, and there's a lot of other interesting things about the inverse functions, but I don't want to just spill the beans. I'll let you guys discover some of those. So on letter F it said, graph your equation from part E on the same set of axes. How are your graphs related? How are your equations related? So the graphs are actually related. It's like it's a regular parabola and then it's like a sideways parabola. And you're supposed to know that they're going to have a line of symmetry right here at the line y equals x. And if you had a table of like an xy table, your x's and your y's are going to be flip-flopped. Like the x's from this will be the y's from this, and that's why this line y equals x is the line of symmetry here. So I think this video is a little too long and I can't talk more about that right now, but as you go through your problems 1-77 through 1-82, you will, I think that they'll lead you through everything else that you need to know.